The CCF 200 press is designed to splice lightweight belting materials in both end and longitudinal joint configurations. Let's look at the overall press and its components. The CCF 200 press consists of a fixed C-frame structure which supports the upper and lower beams. The upper beam hinges open to provide access to the lower platen surface for splice preparation. The lower platen is fixed to the lower beam, and the upper platen is suspended with spring-loaded rods from the upper beam, allowing it to stroke downwards to the product. The pressure bag is mounted between the upper beam and platen. The belt clamp fixture is comprised of fixed lower beams attached to a stainless steel splice surface and floating upper beams, or clamp bars, which are mounted to air cylinders that clamp the belt between the beams. All upper beam hinge and platen pressure functions are controlled by valves on the platen pressure and hinge control panel. The clamp fixture is controlled by switches located on the pneumatic panel as well as the clamp fixture controls panels on both sides of the press. The Model T6T panel has a timer that can be set to switch heat off and sound the alarm when the heat cycle is complete. The upper platen controller Alarm 3 indicator is set as a temperature differential. It is factory set at off so that the alarm relay activates when the upper platen reaches the set point temperature, and this in turn starts the timer. This is a differential setting, so it does not have to be reset when the set value temperature is changed. To change the Alarm 3 value, please refer to your operating manual. Heating the vulcanizer. There are 8 steps to properly heat the vulcanizer. Safety note: never heat the vulcanizer unattended. Step 1. There are 3 positions on the platen switch as follows. On automatic, for automatic temperature control to set value. Off, switches power to platens off, controller will remain energized. On manual, override temperature controller and switch power to platen on. This position has a spring return to off, a safety feature so the heat will shut off if the vulcanizer is left unattended. 2. The vulcanizer should be pressurized to at least 5 psi before heating. 3. Press the reset button. This sets the temperature controllers to begin the heat cycle. 4. Turn the switches to the automatic position to begin heating the vulcanizer. The ammeter will read the current for each platen as they are switched on. The out1 light emitting diode on the controller will light until the process value is close to the set value and then begin to flash. The platen temperature indicator value will begin to increase as the platen temperature rises. Safety note: the platens will begin to get hot. Step 5. The auxiliary temperature meter is used to verify the temperature in either the upper or lower platen. It uses inputs from thermocouple leads placed into the holes located at the electrical end of the heating platens. Use this information to verify the temperature controller output. 6. When the set point is reached, the out1 light emitting diode will continue to flash on and off to maintain set value temperature. Start timing the cure when set value is reached. 7. After the cure time, turn the controller switches to the off position. 8. Press the reset button before the next heat cycle. Cooling the vulcanizer. Safety note: the cooling water may discharge from the platen initially as steam, creating a burning hazard. Ensure the cooling water discharge is not directed at any person or injury could result. When the cure time has been completed and the temperature controllers are switched to the off position, turn on the water supply to cool the upper and lower platens. Leave the power supply connected to the temperature control panel so the platen temperature can still be monitored. When the platens have cooled to an acceptable temperature, the cooling water can be turned off. A typical cool down temperature for a good splice result and safe handling of the belt without the risk of a burn is 150 degrees Fahrenheit or 65 degrees Celsius. The water must be blown out with the air before the platens are reheated. Water remaining in the cooling channels will reduce platen temperature uniformity, increasing the heat up time, and may cause elements to overheat. Important: if water remains in the platens and the vulcanizer is stored at temperatures below freezing, the platens may be severely damaged.